Hello and welcome again to my Physical Science online video lecture and lab supplement series. In today's video, we're going to be doing a post-quiz review, and this is to go over the quiz that you take after doing the solubility lab. So let's go ahead and open it up and see what's inside. Alright, our very first question on this quiz is, what did you dissolve in the water for this lab? Choose all which apply. Let's open up the instructions for the solubility lab. It tells us that the equipment needed is salt, sugar, distilled water, a thermometer, and a water heater such as a stovetop. Now, before even reading further, just based on this, you can kind of guess what the answer is going to be. Probably salt and sugar are being dissolved in the water because presumably you're not dissolving the thermometer or the water heater. And so you read on, and the summary of the experiment, it says you will be determining the solubility of salt and sugar in water as functions of temperature. Alright, so it looks like we're going to be dissolving salt and sugar. Salt, sugar. For what it's worth, some of these other things, namely Kool-Aid, gets used in the simulation that I link to at the top of this handout and in my other video. So I hope that you didn't select that thinking that that's what you're actually dissolving in the experiment, because the things you're actually dissolving are salt and sugar. Alright, next question. As you heated the water, what happened? Choose all which applied. Well, presumably when you heat the water, the temperature of the water is going to be increasing. Now, what about the rest of these? Does the water pressure change when you heat it? No, not really. The vapor pressure, if you were in an enclosed container, would increase, but the water pressure, not really. I guess it would if you were in an enclosed container and you heated the vapor and the vapor pressure increased, thereby applying a larger pressure on the water. But that is not what is happening in this particular experiment. Okay, if we pull up the data that I took for this experiment here, what we see is that as the temperature of the water increases, then both the amount of sugar dissolved and the amount of salt dissolved also increases. So that means that the saturation level for both solutes increases with temperature. So the more that we heat the water, the higher the temperature goes. That means the more that you can dissolve in the water, meaning the higher the saturation concentration. So we should click saturation and concentration. Okay, next question. What is the mass of 2 liters of water in kilograms? So this question, we pull up our instructions, and it tells us that we should begin with 2 liters of water and that you should record the mass of the water. So you can either have recorded this by actually massing it, or you can go back to an earlier lab that we did, which was the building a spring scale. And what you find in the building a spring scale lab is that it tells you, as you scroll down, that water has a known density of 1 gram per milliliter. Now, a milliliter is 1/1000th of a liter, and a gram is 1/1000th of a kilogram. So 1 gram per milliliter is the same thing as 1 kilogram per liter. So if we have 2 liters of water and the density is 1 kilogram per liter, then the total mass should be 2 kilograms. So our answer to this question should be 2.0. Okay, next question. You dissolve enough sugar in a cup of water that the water is saturated at 25 degrees C. You then cool the water quickly to 15 degrees C. What happens to the sugar-water solution? By the way, how could you cool the water quickly like this? One option is that you could toss some ice cubes into it, but of course you would risk melting the ice cubes. So if you melt the ice cubes, then you add some more water. So that's a flawed experiment. The next best thing is to be able to dip the container of water in the ice cubes, but this only works if your container doesn't shatter when you have it very hot and then suddenly make it very cold, or vice versa. So like a glass of water, if it's been very, very warm and you suddenly pour cold water in it, will shatter. In any case, though, we did do this in the simulation that was linked in this, and also I basically did this experimentally, and you probably should have too, because this thing basically is telling you that you're just raising the temperature continuously here. But if you notice that there's more and more of the sugar or of the salt, as the case may be, that is dissolved in the water as the temperature goes up, it implies that you can have less when the temperature goes down. And so if you're at saturation and you lower the temperature, you're suddenly above saturation. That means that you should see some sugar precipitating out of the water. Okay. Question number 5. How do you know when a solution of sugar and water has become saturated? So the options are that the solution begins to change color, a small amount of non-dissolved sugar begins to settle at the bottom of the container, the taste is noticeably sweeter than with distilled water, if more sugar is added it will not be dissolved, the water gains a distinctive odor, the water begins to vaporize more rapidly, none of the above. Well, again, let's read what the procedure actually says. And basically what it says is that you're trying to find the solubility of sugar in water. To determine the solubility, you should add a little bit of sugar at a time and stir vigorously until it is dissolved, then add more, etc., until the sugar is no longer dissolved. You need to add this sugar in known increments, etc. And then you kind of scroll down a little bit and you will know that no more sugar is being dissolved because the undissolved sugar will sink to the bottom of the container as a condensate. So it looks to me like of these options, you have a small amount of non-dissolved sugar beginning to settle to the bottom of the container, and if you add more sugar, it's not going to be dissolved. And that's basically what this set of instructions is telling you here. Okay, so now we scroll down a little more. By the way, you should have seen this in actually doing this experiment. And again, I showed this to you in the simulation in my other video. Okay, question number 6. As you increase the water's temperature, the solubility of salt, well, let's look at the data again. Here's solubility of salt versus temperature. Temperature is going up, solubility of salt is also going up. So the answer is basically that the solubility of salt should increase. In your experiment, depending upon how finely you measured the salt, you may or may not see much of a change, by the way. Again, this is showing that it's going up, but look at the scales. This is 39 per 100 grams. This is about 35 per 100 grams, and we've gone from here's 10 degrees and here's 90 degrees. I think, in fact, that if you follow this to a letter, you don't get quite this far. Maybe there's only a gram or so difference per 100 grams of water. But remember, you've got 2 liters of water in there, So 1 gram per 100 grams is really 20 grams per 2 kilograms. So 20 grams you should be able to notice a difference. Okay, question number 7. Suppose that you're able to dissolve 700 grams of salt in 2 liters of water at 25 degrees C. What is the measured solubility of salt in water? Answer in units of grams solute per kilogram solvent. Okay, we have basically that you have dissolved 700 grams of salt, which is the solute, and we did this in 2.0 kilograms of water, that is the solvent. So 700 divided by 2 is 350, and that is grams of salt per kilogram of water. So the answer here should be 350. Now it says, suppose that you do this at 25 degrees C, where the expected amount is 360 grams per kilogram. What is the percent error for this experiment? Well, the percent error is going to be the experimental value, so experiment minus theory, that's another word for expected. So this is measured and this is expected or nominal, divided by experiment times 100%. So we were just told that this is 360 and this is 350. So the percent error is 350 minus 360, taking absolute value, divided by 350 times 100%. This difference right here is minus 10, and we're taking an absolute value, so that is just 10. So now the question is, what is 10 divided by 350? And then multiply that by 100, and what you get is 2.857. So it would be sufficient here to say that this is roughly 2.9%. So go back here and we'll answer this question with 2.9. Okay, question number 9. You have 1 liter of water at 25 degrees C. The water is currently fresh water with nothing dissolved in it. You begin adding salt in increments of 25 grams. On the 15th increment, amounting to 375 total grams of salt added, you notice that you are no longer able to dissolve all of the salt, and none of the salt from the 16th increment seems to dissolve. You repeat the procedure, again starting with 1 liter of fresh water, but this time at 30 degrees C. Again, you find that on the 15th interval, not all the salt gets dissolved, and on the 16th, none of the salt seems to dissolve. You repeat this again at 35 degrees, and basically same result. So what should we do? This thing says the solubility is the same for both 25, 30, and 35. This says the solubility does not depend upon temperature. This says you should repeat these 3 measurements with a smaller increment size because the solubility of salt is not resolved for your chosen temperature range and mass increment size. And the solubility is somewhere between 350 grams and 375 grams per kilogram at all 3 temperatures. So that one is true. This one also is true. Because you're adding in 25 gram increments, you might want to try adding in 5 gram increments, or even, God forbid, 1 gram increments. You might be there a while, but of course you can jump to the 14th increment and then reduce to 5 grams at a time until you no longer dissolve all of the salt, and so on. You can't really conclude one of these two because of this fact that your increment size is so large. I mean, based on the increment size, yeah, you would check both of these, but really you need to do this and then do this to see whether this is true or whether this is true. This one, it turns out, based on the data that you just saw, is not true. Okay, that brings us to question number 10, and it says, based on your experiment at home, which is more soluble in water at room temperature? Salt, sugar, or they're both the same, or there's no basis for comparison. Well, here's my data: salt, sugar. And here's room temperature for what that's worth, but you can see that everywhere in this range, sugar is more soluble than salt is in water. So sugar. So now we submit it. Okay. And now we see that it's been submitted. And it says 120 out of 100, which is the maximum possible. So this means that this is all the correct answers to this quiz. So I guess we're done here. Well, this is the last quiz for the term. So this is the last of these videos that I plan to make for this term of physical science lab. And I hope that you found all of them helpful and that you at least find them helpful as you use them to study for your lab final exam. And good luck on that final exam. In the meantime, thanks for watching, and so long.